All right. Good morning, everyone. Thank you for joining us for this webinar. We're so happy to have you. We know you have a lot of things you could do with your time, and we're happy that you've chosen to spend your time with us. I'm Stephanie Lynch. I'm OHD's Senior Technology and Research Manager. I'm joined today by our Marketing Manager, Justin Lobdell.
Hello, everyone.
Yes, say hello, Justin. Justin's going to be monitoring the chat, so feel free to drop in any comments or questions, and he'll interject as he sees fit. And we are joined today by a very special guest and a good friend of OHD. This is Aaron Apostolico, and he's the Business Unit Manager for Health and Safety Products for Sensodyne. And Aaron, why don't you give us a little bit of your background?
Thank you, Stephanie, and it's a pleasure being here with OHD today. Thank you for hosting. So I'm the Business Unit Manager based out of St. Petersburg, Florida, where we actually manufacture the health and safety instrumentation. We work with LSI on our heat stress monitoring equipment, I've been in industrial hygiene for a little over 21 years. I'm a certified industrial hygienist and a certified safety professional. And I have many years of experience performing heat stress monitoring as well as other industrial hygiene monitoring in the field. So I'm going to talk a little bit today about our line of heat stress monitoring equipment.
Very nice. We're super excited about it. We appreciate you being here.
Thank you.
Okay, I'm going to give just a little bit of background before we let Aaron jump into his kind of meat and potatoes. So these are just some sort of foundational information, right? So I think we're all hearing a lot more about heat stress. And so heat stress is the overall burden and load in the form of physiological stress that exposure to excessive amount of heat is putting on our bodies. So several factors play into this load, and heat illnesses result from heat stress. So those heat illnesses have a wide range of symptoms and severity, and they also don't have to progress. You don't necessarily start with sort of a lower level of heat illness and then progress to a higher one. You can go straight to heat stroke. And people also have very different levels of sensitivity to that heat stress. So we'll kind of talk a little bit about that. So this is just to show those heat illnesses, visually based on their severity. As I mentioned, this is not really a progression. So you don't have heat rash before developing heat cramps and so forth and so on. So heat rash also down here in the South, we call it prickly heat. I don't know if you've ever had it, but it often occurs in hot, humid environments. And that's where that sweat is not going to be able to evaporate off of your skin. And so it's going to clog up your sweat ducts and you're going to get a nasty rash on them. Have either of y'all had heat rash?
I have, yes.
And so, it can come on quite quickly, right? And then it takes so long to go away. And then every time you get it, it seems like it's just easier to get next time you have that exposure. So, lots of us probably have had heat rash, but there's also heat cramps. And I would bet most of us have had heat cramps. And mine in particular, for some reason, don't hit me when I'm actually performing the activity usually. Usually it's when I go to lay in bed that night, when I'm finally getting to relax and my leg just, takes on a life of its own.
And that's usually also combined with dehydration.
Oh, absolutely. Mm-hmm. So those are those painful muscle spasms you get, and they're essentially caused by sweating while you're performing just strenuous physical activity. I think a lot of us would associate them with sports, but they absolutely happen on your job when you're performing strenuous labor, right? Those can also occur alone, or they can occur with some of these other heat illnesses. So just be aware of that. Okay. Then the next sort of one we want to discuss is heat exhaustion. Heat exhaustion is going to be a more severe stage of heat illness, and it's going to happen when you sweat excessively, and it's causing you to lose too much fluid and too much salt, too much of those electrolytes. You will still sweat, but one of the kind of telltale signs is that pale, clammy skin. You might get a headache, you might get dizzy, your stomach can be upset. You actually can't experience fainting, you can fall out. That's something that can happen from heat exhaustion. And then our big, bad heat illness, of course, is heat stroke. And heat stroke, it's going to take you out. That's when you're going to get that hot, dry skin. You've stopped sweating. And once your body stops sweating, your heat can just go up real fast. That internal core temperature is going to rise very quickly. Another interesting thing about heat stroke is sometimes it doesn't kill you immediately. What it does is it causes damage that's going to shut down some of your major body organs, and you're not going to be able to recover. So it's actually kind of after the fact, you're having these lingering things. Another thing is that with each of these, we talked about just the rash being where, it comes on and it's going to come on more easily. If you experience any heat-related illness, you're going to be more susceptible to future heat-related illnesses. So just keep that in mind. So these are some of the risk factors that are going to contribute to that heat stress on your body. So I'm not really sure how well you can see this graphic. These are the environmental and individual risk factors for heat stress, and this can be found at NIOSH. I got this right off of NIOSH's website. So some risk factors, of course, are your environmental conditions, right? How hot is the air around you? How much is that air moving? Radiant heat exposure. So typically when we're talking about that, we're talking about the sun, but since we're talking about industry today, there's lots of radiant heat sources out in industry, right? Mm-hmm. So others are related to your work. How strenuous is your work? What gear do you have to wear to perform that work? All of that's going to impact that. And then still others are personal. So that's going to be your age, your fitness level, medications that you may be taking, alcohol use, caffeine consumption, just your general level of hydration. These are all personal factors that impact our susceptibility to heat illness and our reaction essentially to heat stress. And you can see how, especially if you're out there working in safety, you can see how accounting for some of these individual risk factors could be quite tricky, right? You would need to have a really good relationship with your employees to get the feedback you would need to know about some of these things. So
let's also mention, with the personal factors, it's magnified if you're not acclimatized. And I'll talk a little bit more about acclimatized versus not acclimatized. But if you're not used to that heat, it takes your body a while to adapt to those conditions, and that can add to those personal stress factors.
Such a very good point. I don't know the statistics, so I don't want to state it, but I know a large majority of the heat illnesses that happen out in the workplace are to those people who just started that job and were not properly acclimated to that work or to that heat. So we know that's a big one.
Absolutely. And I'll just add to that most people think that heat illness is relegated to just the South where I live down in Florida, where it's, sunny and hot all the time. But the truth is, a lot of those OSHA recordables actually happen in more northern environments because of that acclimation. When you're moving from those cold, outside conditions, maybe to a hot indoor work environment, and you're not acclimatized to it, you can actually have a higher incident rate.
Yeah, that's absolutely true. Such a good point. Okay, so of course we all care, right? We care about this because we care about our employees. We want them to go home in at least the same condition, if not better, than what they came to their job, right? So that's why we care. But I found some of these just very startling, and they're worth mentioning. So every day, 11 workers are seriously injured or die from heat stress. The 3-year average of work-related deaths caused by heat has doubled since the 90s. And I think I should mention that this is likely underreported. There's a lot of research out there that suggests that ultimate injuries that may have had a cause that was related to heat exposure. So you develop that confusion or dizziness, and maybe you have an accident, or you have that heat exposure and it fogs your glasses, or it makes your hands sweat, and now you become more susceptible to having that accident. So there's this theory out there that a lot of this, we have accidents that are related to heat, but heat isn't identified as the kind of root cause.
Absolutely.
So heat is also the leading weather-related killer, which shocked me. So that's more than tornadoes, hurricanes, all this stuff combined.
Wow.
So it's over 500 a year, according to the CDC. And no matter the cause, I'm not trying to get political here, it is getting hotter. Like objectively, world's getting hotter. So we're going to have more heat, and it's something that we just need to care about.
Absolutely.
Okay. So if that wasn't good enough reason for any of y'all to care, then guess what? You're regulated to do so. And I wanted to make a point of this because you've actually always been regulated to do so. You are required by OSHA to provide your employees with a workplace that is free from any recognized hazards that are likely to cause injury or death. And so this is how heat injury and illness can be cited, and this is how it could always be cited. So there's also a national emphasis program, which you may have heard of, that was very recently released, which we'll kind of touch on.
Yeah.
Oh, go ahead.
Before we move on to that, the national emphasis program, which you're going to talk about here, but there's also state programs, and states have actually had for many years some heat stress, and that includes, I know, California, I think Washington State has had some. So there's been several state OSHA programs that have actually had regulations and standards on the books for many years now. And it's just coming around because of, at a national level, they have seen it as such a critical root cause, as you mentioned, to so many different injuries, whether it was a direct heat illness, or like you said, it was heat that may have caused another injury, whether it was, a slip, trip, fall injury, or another type of injury that the primary injury was more of the focus, as opposed to, the heat stress, which may have led to it.
Yeah, I'm so glad you mentioned that. I actually just saw this morning where California's OSHA, their second most highly cited issue was heat stress. So, yeah, very good point. But so we probably all have heard about this national emphasis program. So just placing even more emphasis on what we know is a very serious issue. So since April of this year, OSHA has placed this national emphasis on heat-related illness. It does apply to all industries, but they do target those that are considered at risk. And there's quite an extensive list of those. If you're not sure whether your industry is on there, you really should go check that site, because they are planning to double their amount of heat-related inspections. And then any OSHA inspection is going to include them asking you about your heat-related prevention program. Another kind of important thing is the threshold, where they're then identifying these heat priority days. So if it's above 80 degrees Fahrenheit and the humidity is above 40%, OSHA is going to call that a heat priority day, and that's going to ramp up their efforts, at least for these regional offices. So just some kind of critical information there. Okay, I'm now going to let Aaron take the lead. He's going to roll into what may be, even more valuable is how maybe, or some solutions, right? Some things we can do.
So I definitely want to talk about some solutions here. Let's tie it back a little bit to OSHA and this national emphasis program. When OSHA shows up on site, or if you have a state program, they generally follow what's known as the OSHA technical manual. And I'll cite this section. It's section 3, chapter 4, is specifically related to heat stress and how they monitor for heat stress. And that's using a WBGT instrument. And for those not familiar with what WBGT is, that's the wet bulb globe temperature. And the wet bulb globe temperature is really the most accurate way to identify all the heat stresses that an individual worker sees on, as applied to them, including that natural wet bulb temperature, which is really an indicator of their ability, to cool itself through evaporative heat.
Okay.
All right. So we'll get into that a little bit more. But as we talk about our different solutions, we have, the different monitoring equipment. So there are some standards out there, some international standards that actually govern this. So, while our focus here is with OSHA, this has been a standard that has been worldwide for several years now. And really in practice, mainly in Europe, but in several other countries that have adopted the ISO standard as well. So that is ISO standard 7243. They came out with a 2017 version, which kind of was an update to the standard. And this really talked about devices for monitoring those physical, ergonomic, thermal environments with a focus on heat stress because of the number of injuries related worldwide to these thermal heat strain and stress issues. So there are both portable and fixed heat stress meters that are on the market. All of them have something in common. They have three main sensors. So those are going to be your black globe temperature. All right. So you'll hear me refer to that as the globe temperature today. There's the ambient temperature. You may also hear me refer to it as the dry bulb temperature. And then there's the natural wet temperature. All right.
And so these three things are just helping us better quantify the exposure of an actual person, right? Because there's all these different factors.
That's right. Okay. So, you know, a typical thermometer that you would have in your house is really just a dry bulb thermometer, and it's only measuring that dry bulb heat. But knowing how much, you know, humidity is in the air, and then the ability for it to evaporate through air movement and cooling. So that's what that natural wet temperature is going to measure. And then the black globe temperature really takes that radiant heat, mentioned radiant heat or solar load. So, you know, through those solar rays and ultraviolet, these can also contribute to heat stress. And, you know, this is why you can get sunburned on a cloudy day. All right. So that's part of that heat load that the, you know, outdoor solar load can take into effect. So for the WBGT method, we can measure it both indoor and outdoor. So that's with and without the solar load, presence of the sun. But there's other results related to a WBGT effective heat stress, and I'm going to talk about that a little bit more. Here you have illustrated several different systems, and this can include some units for surveying. We have some portable outdoor units. We have some fixed outdoor systems, as well as some fixed indoor systems. And I'll talk about all three of or these multiple solutions as we proceed. So the intent of these heat stress monitors is really to assess the local environment for the workers. And what they can get out of that, as you mentioned, New York, the heat strain conditions, the heat stress, cold stress, and even hypothermia. So in addition to obviously the hotter environments, there are times where we want to measure those colder environments too, because those can also affect worker conditions and injury as well. So the heat stress equipment can be used for both monitoring heat stress as well as cold stress. I do want to call out that term local environment. Many end users would, you know, go and use their mobile phones. And while that's really, you know, a good accessible tool, the truth is that when you look up your local weather, it's at a central location, a lot of times airports or at a local weather station, and that can be miles away from your site. And the conditions that, you know, your phone is reporting are not necessarily the same conditions you have at your local work site, and especially if you're indoors. So having a WBGT monitor is really getting that local environmental condition that the employees are exposed to.
That makes a lot of sense, because I know I have the OSHA heat stress app on my phone. And like you said, it's, you know, it's maybe good for a spot check, and it does give you some cool, there's a precaution thing you can check on there, and it'll tell you some things for that environment. But you're right, it's not measuring right where I am, and it's also not really measuring everything, right? It's only doing
correct. Right. And you're not getting that natural wet
temperature.
Yes, and it's not taking into account air movement. So getting, you know, a monitor that is local, that can do the full WBGT sensor array is critical for really seeing what your employees are exposed to at that time in that location.
And is that really OSHA's expectation for how you would?
It is. And you know, they do cite heat index as kind of an indicator of, yes, today's going to be a priority day to go out and measure. But when they get on site, they are going to be using WBGT meters to actually assess the effective WBGT. And I'll talk about what that includes because they also look at other factors like metabolic rate and clothing adjustment factors. So the primary requirements for a heat stress monitor are laid out in that ISO standard 7243. But they're also laid out in OSHA's technical manual. As I mentioned before, in section 3, chapter 4 of the OSHA technical manual, they call out what is a WBGT meter and what it's comprised of. So it is those, 3 core sensors. It also has a relative humidity meter in there. So you can get heat index out of it at a local location, but more so, OSHA is going to be concerned what the WBGT effective value is.
Okay.
Right. These instruments, are a primary instrument, and your sensors are calibrated, and they really should be accurate within a half a degree Celsius or about 0.9 degrees Fahrenheit. So, you're holding it to a tight standard, because even, a degree or two can really be the difference of pushing a worker over the line, depending on their workload.
Well, if you think about a good faith effort to comply with this national emphasis program, if you already know it's going to be hot where you are, like you're getting that heat index, then you're going to want to show that you've done something more, that you've set something up to know those environment. Yeah, that makes sense.
Absolutely. The other benefit is you don't want to necessarily do too much, because when you start putting controls in place in these work environments, it can reduce production, because you might have to go to a work rest ratio that's appropriate for the WBGT values and the exceedance of the threshold. So in order to prevent injuries, you may reduce workload, but you don't want to do that more than necessary. So having a WBGT meter might tell you, yes, now we're in a work condition, and maybe that condition is present for 4 out of the 8 hours. But if it drops below it, you may be able to resume normal working activities.
Well, and one thing OSHA recommends is offsetting hours, right? So performing that work earlier in the day or later in the evening, not later in the evening, but when it starts to cool off, So there are things you can do to maybe up that productivity. I would also contend, because I'm working out in different boundaries and stuff. I hate the idea that anything you would do for safety might reduce productivity. Because I will say, your employees, if you're just wearing them out every day and they're just going home exhausted, you're not getting your best out of them, right?
Sure.
So if you're showing them, number one, that you do care about them, that can improve job satisfaction, that can improve
morale is very important.
It's very important. And so then, there's a trade-off, right?
Sure.
And it can go either direction, but ultimately you're always better off caring about your people, for sure.
Fantastic. So beyond the benefits of preventing illness, there's secondary benefits for actually improving productivity by having a proper work rest ratio in place when these conditions are present. Mm-hmm. And in order to know when those conditions are present and then not present, mm-hmm. having, meters on site to actually measure that are very helpful. Let me continue. So some additional features related to these instruments. You can kind of see I have a couple of these WBGT meters right behind me. These meters have a 2-inch black globe on them. The ISO standard references a 6-inch black globe. So we offer both the 6-inch and the 2-inch black globe. In order to convert down to a 2-inch, there is a calculation that follows the ISO standard built into the machine, which allows it to convert from the 6-inch solar radiant heat calculation down to the 2-inch. So that is already built into the instruments.
So it's really just a practical consideration. You don't want to be wandering around with one of these with that 6-inch globe on there.
I mean, it's a preference. Some people want the traditional ISO compliance standard, which uses the 6-inch, but for portability, you can use the 2-inch. But I do want to assure people that even though it is the 2-inch, it does comply with the ISO standard.
Perfect.
Right. We talked about measuring wind speed. So the natural wet actually has a wick, which as the air movement goes across the wick, it reduces it. So you are measuring somewhat of the air movement with the natural wet temperature by itself. However, there's other values to use a anemometer, which measures wind speed, or a wind cup sensor, and you can add those to these units. There is a way to connect them up to the units where you can record that data as well. And that again goes back to the local conditions. So let's say you might have controls in place where you add fans or you have local ventilation that you want to be able to identify, okay, we were able to reduce the heat by so much airflow, and we can monitor what that airflow was and those conditions of that control that was put in place. So in addition to the monitors, we do sell accessories such as these hot wire anemometers or a wind cup sensor that can actually plug into the instrument, and we can data log that data as well as your WBGT information.
Okay, so just to get even more honed in to what your
honed in on
conditions
what
are,
those
your
local
local.
environments, absolutely. Now with our fixed systems indoors, as well as our fixed outdoor and portable systems, you can download that data as well, and you can use the software, which allows you to manipulate it and come up with some, calculations that are after the fact. But if you wanted to, you can actually connect to some servers, and I'll talk a little bit more about that, and get some real-time information, including having real-time alerts if those thresholds are exceeded. So those alerts can be through like text, SMS text messages or emails, but you may also connect a visual or audio alarm system. So those are some other options that we can do or utilize with the fixed and outdoor and portable systems.
Very cool.
So actually here, sorry, this is a slide. It kind of shows you some of those accessories. So in that upper left corner is a hot wire anemometer. The one in the top middle, that's your wind cup sensor to measure that airspeed. Of course, on the upper right, you can see the alarm, where you can have just a visual or just an audio, or if you want to have both, it can be set up with that. The satellites can communicate to a master hub, but we also have repeaters, which can extend the distance that these satellites can be from a receiver. It should also be noted that for those outdoor systems, if they're in remote areas where you might not have power, you can actually power the systems through a solar panel. So we actually sell the solar panel kits, which can connect to a main hub, which is going to have your alpha logger in it that is also powered by a battery, but that battery is now charged through a solar source as opposed to AC power.
Oh, very cool.
So now I want to get into really our different types of systems that we have. I mentioned the heat shield, which is our primary survey tool. So this is a great screening tool. It's typically used by health and safety consultants inside health and safety teams to really get some baseline data. These data log, and you see the base unit here and the optional satellites, and it has 8 megabytes of storage, which is actually, weeks and weeks worth of storage data. I mean, that's a tremendous amount because it really doesn't take up a lot of data on the display. And that can be downloaded using our HS Manager software. Mm-hmm. And then you can do some post assessments through the PC software, which comes with it. There's a few different models. As I mentioned, you can get it with the 2-inch bulb or the 6-inch bulb. If you want a base unit without a radio signal, you can get it without the radio signal or again with the radio signal. Okay. The radio signal is needed with the satellites. And the advantage of the satellites is you can actually get 2 satellites with the base unit, and you can position them, in multiple distances away from a heat source. So say you had a furnace and you wanted to say, okay, well, how far back is a safe condition. Mm-hmm. So I might want to monitor in, 3 local spots. Maybe there's a walkway nearby. I could do it that way. As we all know, also heat rises. So sometimes you want to look at stratification. Mm-hmm. So maybe a specific distance away from a heat source, but you want to measure, at ankle height, kind of your torso, and then like head height. Mm-hmm. So you can look at it as a stratified layer. And we do sell it with some accessories like tripods and even mounting poles to bring it up even higher to higher conditions as well.
Yeah, I know whenever I've done the surveys, I've always had to have it at a certain height. It was like 1.1 meters or something where you were.
Okay, you can follow the ISO standards, and they pull back from the ankle, torso, mm-hmm. head, I think kind of standards, but it's still an option. It's still performed today. So that's something you can do with the base and 2 satellites.
I just love the idea of some sort of like heat mapping, essentially, because I think that would really show, if you did have OSHA come in, like you would show that you really are performing that hazard assessment, which I know that's just, it's going to mean everything if you've really done some assessment.
Very similar to, for safety professionals and other IHs, the way you would do a sound level map. Mm-hmm. So
that's exactly what I was thinking.
You know what areas, are hot zones, mm-hmm. But if you want to have an exclusion zone or inside this area, you have to be more cautious or limit your time, beyond a certain point. Just like you would need to wear hearing protection within certain areas, where you have high sound. So our stationary multi-position, this can be used in bakeries and foundries, automotive manufacturing. I know glass manufacturing has very, hot furnaces where, they have to melt the glass, aerospace defense. I mean, there's a number of applications that can use these fixed systems. Most commonly, they would mount them to, columns or, a wall location, in an area where workers are exposed to those higher heat sources. Now, these systems can be tied into a real-time dashboard. They work through that Zigbee radio signal. That could be up to 300 meters outdoors, but indoors, it can be far less. And it's really dependent on if there's structure in the facility. So that could be walls or other equipment or process equipment that can reduce it. So in order to gain that extended distance away from the hub that receives the data, we also sell repeaters that can be also put into the facility. So you don't need the full, WBGT meters to communicate. You can use the repeaters to get it back to the hub.
Oh, you know what? I forgot to even ask, because this was an interesting question that I've definitely heard a couple of times. How far can that satellite unit on the WBGT, the heat shield, how far can that satellite be placed away?
So with the heat shield units, it's really up to 300 meters. And that's outdoor with line of sight. If you're, outdoor and there's like other structures outdoors, it could, drastically reduce to maybe 50 meters.
Okay.
So it's really dependent upon, if you have a clear line of sight or if there's structure in the way.
Sorry to go back.
No, not a problem. Within the units, again, you can calculate your WBGT with and without solar load. And you can also, I'll talk a little bit about how we get to the effective WBGT, as well as comparing it to reference WBGT values to know what the thresholds are, and that might below it or above it.
That effective value, that's what OSHA is going to be?
Correct.
Okay.
Yeah, and I have another slide coming up where I'll really talk about that effective value. Before I leave this one, again, an advantage of this is if you have it set up in your facility, you can actually set your thresholds, and then if your thresholds are exceeded, it can actually send a text message or an email to maybe a supervisor who might want to institute some of those workplace controls, as far as either rotating employees or work rest ratios, maybe bring in some additional fans or cooling. So there's other things that they can do if they know those thresholds have been exceeded. So, having that ability to either have a local alarm or send them an alert to their phone or email might be beneficial. And that's something that you can get customized with these systems.
Absolutely. I know a lot of safety and health professionals who are over multiple sites. So being able to have something like that that could alert you of a site-specific issue, that could be very valuable.
Absolutely. So here we're showing the portable indoor and outdoor system. So as opposed to the fixed system, we have this portable system, and you can actually kind of see it. It's set up behind Stephanie here. This system sets up on a tripod, and it has all of your WBGT sensors on here. It also has a antenna that can be used to transmit data, again, through that modem to your that text message or email, or it can actually feed directly into a server system where you can download it and do the data calculations afterwards. And or if you wanted a real-time dashboard, you can actually use it and customize a real-time dashboard. So these systems are great for construction sites. So I know that one of those industries that you talked about, OSHA, targeting, we have a lot of incidents related to these construction sites. So this would be a great application for this solution for those types of facilities where they're moving around. Now they might be at a construction site for weeks at a time. Again, having a portable system like this would be perfect for that application. And it is weatherproof. So this can, sit outside and be exposed to those elements.
Well, my first thought was, of course, like Auburn football practice field.
Sure.
I want to check my boys,
Absolutely. So sport facilities, military training sites, where they're moving from location to location. Now, very similar to that, you can have a stationary outdoor system. So if you know that they're going to be in a set area, whether it is a sports complex, you might have a stationary one set up, adjacent to the field that, is a specific site. This could be hardwired in and even tied into a control system or maybe to a control room where it can be viewed on a dashboard. These systems, both the portable system and this outdoor system, can be powered by a solar panel as well. So if there's not that, AC power available, these systems can be powered, and even have that meteorological, information as well.
The solar panel just seems so practical because you're thinking about all these places where you're, worried about that solar load anyway, right? So now you're getting to benefit from, at least take some power from that solar energy.
Absolutely.
Very cool.
Absolutely. And if you're moving it around, you don't want to have to connect it or run extension cords or have generators. So there are batteries inside the box that has the alpha, but to keep those batteries charged, you really want to have a power source. And that, again, could be AC power or it could be through the solar panel. So I talked about the different communication systems. I do want to note that these communication systems do not apply to the heat shield, but really to those fixed systems and the indoor-outdoor portable systems and the fixed outdoor system.
Well, like you kind of mentioned, these were used more for your survey stuff, right? Yeah.
So in order to really, identify what the instant, you can check. So the base unit does have a display and you can scroll through that display, but you physically have to go up to it and, you can see where you are throughout the day, but you have to, check on it.
Right.
Whereas the fixed systems don't have a display, but can alert you through, a modem and using like a SIM card to transmit that data and then send you that email or text message to let you know that threshold has been exceeded.
Well, yeah. And so I just really wish that, I'd had different equipment. When I worked for the Army as an industrial hygienist, I had my WBGT, my WBGT, and we had to do just what you're talking about. It was set up outside and it was out front of our office. So again, I'm kind of missing that local environment factor, right? Because I'm not exactly where the soldiers are. And I would have to go out every 15 minutes and, check it. And then we had levels where at some point you alert, command teams of dangerous conditions, but it was, it was not a
It'd
great.
be nicer just to set one of the
So we could set a
systems
portable system
out there, and then it would still alert you and them because you could send multiple text messages, to multiple people. So maybe it sends it to command, but also to, your drill instructor to let, them know, hey, we're above a certain threshold.
Yeah, such a great improvement.
And, even on those systems too, if they don't have, a cellular device with them, they can have that local alarm system. So, a flashing light or an annunciator to let them know, hey, you've exceeded a threshold.
Very cool.
So I want to talk a little bit about the firmware. So the firmware has just recently changed and we're instituting an update to our firmware.
And I don't want to be wrong, but didn't you participate in some of these changes?
I did.
Okay.
So over the last month or so, I've been working with our LSI partners to institute some of these changes, which are really going to account for this effective WBGT. So that's been a part of the ISO standard, but it wasn't necessarily built into the instrument. And now what we've decided, because of the ACGIH, which is the American Conference of Governmental Industrial Hygienists, which is the really the reference that OSHA has been utilizing. And again, they reference in their OSHA technical manual the ACGIH standards and tables that are utilized for your effective WBGT.
So those TLVs.
Yes, those are the TLVs and action levels. So I'll talk a little bit about both of those. So, previously, the instruments really just measured, your 3 temperature sensors, your dry bulb, natural wet bulb, and your globe temperatures, relative humidity, and then if you had an anemometer or wind cup sensor, your airflow. But now you can manually input what you want to measure either with or without the solar load. So those are different calculations, and I'll show you what that is momentarily. You can also select whether your workers are acclimatized or not acclimatized. You can also select from a drop-down list what the metabolic rate was. So the metabolic rate, which is measured in watts, is really associated with the workload of the activities that are being performed by the workforce. All right, and then lastly, I mentioned it earlier, but it's critically important, is the clothing adjustment value, all right, the CAV. And that really says that when you're, exerting, force, you're expending this energy, it is magnified if your body cannot, dissipate that heat. So when you have, non-breathable clothing or double layers, you want to account for that. And it actually increases that effective WBGT, which then you utilize to compare to your reference, which is that TLV or action level.
And would OSHA have the expectation that you were considering those?
They do, and that should be a part of your program. So when you talk about that, heat injury prevention program, you want to take into effect, what your, clothing is, what PPE they're wearing, or it could be even just their standard uniform, common, flame retardant, clothing, again, doesn't breathe as much and can be heavier. So you actually add temperature to your WBGT index to get that effective WBGT, which then puts you more in line with what their person is experiencing.
Right, because it is increasing that burden. That
It is.
Okay.
Absolutely. So here we show what, the calculations are for the WBGT index. And the WBGT index has two calculations based on whether it's indoor or outdoor. So outside, you take into account that solar load, which has that natural wet bulb temperature, dry bulb temperature, and globe temperature. Whereas with the inside, you're really looking at your natural wet bulb temperature and your globe temperature only. So I talked about the WBGT effective. There's a drop-down menu in the instrument. So in the heat shield, you'll be able to manually select what your clothing factor is. So you'll see a list, which is kind of like a drop-down list. You'll scroll through it and you can select, am I in long sleeves and woven pants, or am I in other, double layer clothing, or, maybe I'm in an operation where I'm doing abatement and I'm wearing, a Tyvek suit. All right. And these types of suits, are additional barriers that block that. So, if you're wearing a vapor bearer coveralls, because they don't breathe, I've worn them and I can tell you, they fill with sweat and you can overheat real easy in those. And that's why you have a clothing adjustment factor of 10 degrees Celsius. So, that's huge. In addition to those, I do want to note, and it's bold on the screen for a reason. You take into account all of those which are not bold, but if you're also wearing a hood and this covers your head and neck, which, as you know, is a main way to dissipate heat through your head.
Right. They say, if your feet are cold, put on a hat.
That's right. So if you add a hood to any of those above clothing factors, you're going to add another degree Celsius on top of adding those other factors. Can you click back on? I think you need to just click on my screen real quick. Yep, that worked. So now you may understand how we get our WBGT effective value, but we still need to compare it to it. So what is the reference? And the reference point is not a straight line reference point. It's actually a curve based on the metabolic rate. So I mentioned the metabolic rate. It's broken up into 5 categories. So that is your rest. So if you're sitting, this is really at rest, kind of like we're doing right now, very low, heartbeat is just relaxed. Light is you're walking around, but you're not doing real heavy lifting. Moderate gives you, a little bit more, active, you're using tools, you might be carrying some things. So, you're getting your heart rate up a little bit. Heavy is when you're really out there, you're wearing, those, layers, your heart beats higher, your core temperature starts to raise a little bit more. And then there's very heavy. And this is when you're, really exerting yourself. And, you're laying brick and you're moving, you're climbing, ladders, you're moving heavy things, you're working in silos, you can really get into that heavy workload, and you're able to select that. And depending on which metabolic rate you're in, it'll line up with what your threshold value is. So what we've done is we've instituted this DTTL, which is the distance to the limit. It's your delta. So you're able to see where, are you over the limit or how far you are to the limit. So this gives you an idea. So on that given day, you might be, 1 degree, just below the action limit, which is also used for those not acclimatized workers. Or it might say that, today I'm, 1 degree above it. So you'll know what that distance to the limit is, whether you're exceeding it or not. And then,
so you know how concerned to be.
Exactly. And then it's also calculating your heat index and your humidex, which is really used in Canada. And then if you have those wind cup sensors or the anemometer, you can also do some calculations for thermal comfort.
Okay.
So here is that graph showing that WBGT effective value. So you calculate your WBGT index and you would choose, with or without solar load. So, in this example, we're saying your WBGT without solar load is calculated at 23 degrees Celsius. However, we're looking at an employee that's wearing polyolefin coveralls. So we're going to add 1 degree Celsius to get our effective WBGT of 24 degrees. You then take that value and you look at what your reference thresholds are. So in this particular case, we are saying that the workers are subject to a metabolic rate of 400. All right. So on this scale, you follow that up and you can see at 400, the action level is set at 23 degrees and your reference for your threshold limit value is at 27. So before we had said that our effective WBGT was 24 degrees Celsius. So if that worker was not acclimatized, they would actually be 1 degree above and exceed that action level. Now, if they were acclimatized and we were looking at the distance to the TLV, they'd be 3 degrees below that value. So this is good information for your site safety manager, your industrial hygienist to know.
It's like a new guy comes in, he shouldn't be there, right? He's not going to make it for the whole day. And then your other guys, though, if they are acclimatized, then that they're okay.
Yep. So you might go to the TLV and say, okay, so at 24, we're getting close. We're going to watch it, but they're not above that threshold yet. But that not acclimatized worker, we might have to do a work rest ratio to really prevent that injury. So it's giving you both those values on the instrument, and you can actually see it in real time by going and checking the instrument.
Very nice.
So some additional measurements, again, using the satellites, you can, collect those additional positions around the workers. You can look at average values for individuals. You can look at things like time history, variations, and then the heat index, which is typically used in the US and in Canada. They use something called the humidex value, which is very similar, but at a different scale. So the HS Manager software is what you would use when you download the heat shield instruments. And it may be hard to see, but you get basically your timestamps going down the left side column. And then you have all these columns. They'll show the individual temperatures of each one of the 3 sensors, plus your relative humidity sensor. And then it'll do a calculation of what your WBGT is indoors, your WBGT outdoors, as well as what that heat index is.
Yeah.
For those that can read Italian, but really, this is showing you what those values are and then it calls out the unit of measurement. So you can switch it from degrees Celsius to degrees Fahrenheit. But it can give you a chart, so you can actually download a chart so you can see how it performed throughout the day. As you know, if you're working outside, or maybe there's certain tasks or activities where you're opening a furnace and, it's opened, for 30, 40 minutes at a time, 5 times during the day. When you download your time history chart, you can see where the WBGT really spiked up during those conditions and how long those conditions were present for. So that's an advantage of, downloading the data and looking at the time history chart, so you can see over that entire work shift the different levels of exposure. And I want to be mindful of time because I know we're getting close to it. I'm almost done here.
Will you actually hand me that keyboard real quick? And then just let me know when you want me to press.
Sure.
Do something real quick. Thank you.
No, not a problem. So, this is close to the end here, and this just kind of summarizes what our measurements really do. And that includes that, thank you, that's helpful. The references to the ISO standards. So, you're able to get the individual measurements, you're able to get your WBGT index, and then by manually selecting your clothing adjustment factor, you can now get that WBGT effective. I do want to tie this back to the OSHA NEP. They do reference in that OSHA technical manual that they are looking for that WBGT effective, taking into the clothing adjustment factor, and our instruments allow you now to enter in that factor so you can account for what that burden is on those employees. It also allows you to select that metabolic rate so that you then have the accurate reference points, so you know that you're going to be above or below what those thresholds or action limit are. And then lastly, we talked about the TLV and action level with the ACGIH for the acclimatized and not acclimatized workers. So if you have an acclimatized worker or not acclimatized worker, you can use those WBGT effective values to determine, the appropriate response conditions based on what their reference WBGT is.
Very cool.
That concludes my part.
Very cool.
Perfect.
All right. Do we have any questions?
Yeah, and that was a great time for any questions that anyone may have.
It looks like there's a couple in the box.
Yeah.
Okay, I see one there that says, does the wick need to be kept wet? Yes, the wick does need to be kept wet for it to continuously measure that wet temperature, wet bulb fluid temperature, whatever.
Yeah. I will
Natural wet.
Yeah, it's your natural wet bulb temperature. Depending on the environmental conditions, the reservoir, which is relatively small on the heat shields because they're more of a survey tool, they can last, an entire day, but depending on the conditions, you may go through it. What's interesting is if the natural wet temperature is the same as your dry bulb temperature, that means your reservoir is empty. So it's a good indicator that you can actually figure out, hey, when they start converging to that same temperature, you're going to need to replace water. Now, on the outdoor and portable systems, and even the fixed systems indoor, because you don't want to have to tend to them as much, they have much larger reservoirs. So, these are relatively small, but on the unit that's actually right behind you, you can see the water reservoir, which is that front reservoir, is much, much larger.
Yeah.
I'll also note that, you should utilize like a deionized water and not necessarily use tap water because you don't want the salts that are in it.
Right.
So utilizing, purified and deionized
distilled water.
Distilled water.
Yeah. Okay. Second question. Oh, go ahead.
I was saying we did have a great question regarding clothing and metabolic heat. If y'all wanted to touch on that one as well.
Okay. So I guess you should read the question first. So asking about clothing and metabolic heat, personal diet, hydration, etc. Is it better to adjust the system based on the worst case? So non-acclimatized wearing bulky PPE if you're working on a construction field. In my opinion, that's going to be very situation specific. But if you do know that that's a situation that could present itself, then I would absolutely be more conservative as opposed to lightening up, I guess. But if you're not going to have someone who's coming in totally unacclimatized and wearing a bunch of bulky clothing, I don't think you should do that. That would mean you don't have to be quite as conservative, right? If you make sure that that's not a situation that
Sure.
would present itself.
The great thing is you get the best of both worlds. If you want to put in the more conservative assumptions, you can still take the data. When you download it into the software, you can actually run different scenarios. So if you wanted to change your clothing adjustment factor, once you download the data, you can do that and see what it would be in the different clothing adjustment factor or at a different metabolic rate.
Yeah.
So you can actually, once you download the data, you can actually run different scenario calculations with the software. So that's an advantage that you have. So maybe you do assume, maybe the worst condition on the site, but if you want to, you can actually take that data and use the software to do some post-analysis calculations.
Very good. I see another one here from Emily. It says, what WBGT reference should be used while the workers are in process of being acclimatized? Should the non-acclimatized reference be used for most of the day and the acclimatized limit used for a couple hours in the day? My understanding is that the remaining below the non-acclimatized limit will not permit, I'm assuming that's going to be acclimation.
Yeah.
Is that correct? Do you want to take that one? Or?
I'd be happy to. Until they are acclimatized, and it really depends on the workforce and the conditions on the site. They could take days and sometimes weeks to become acclimatized. It really depends on what their starting conditions are and how hot the work environment is. So you really don't want to, change it in the middle of the day. Ideally, in this condition, until they are acclimatized, you would use that action level for the non-acclimatized workers.
So, and OSHA recommends a 20% increase per day, giving you a week to acclimate. But I would have to assume that they're basing that on someone who we mentioned earlier, if you're in the South, then they're already here. And but that wouldn't be the same. Like I wouldn't treat someone who just moved from Ohio and go to my job at the steel mill and has never worked in the steel industry and is in the South now. I mean, that's a lot of things to consider. And then I would be more concerned with someone who I either didn't know their health history or if I did know certain health risk factors that they did have.
Absolutely.
And like you said, it could take up to, I've seen it take weeks.
So the preference would be to leave it in the non-acclimatized
Absolutely.
until you really feel comfortable that they've reached that value.
I agree. Okay.
Perfect. I think that's all the time we have
Okay.
for now. We will be,
questions?
we had a couple questions about are the PowerPoints available? We will be sending out the PowerPoints as well as this live recording by the end of the day to everyone that was registered. So feel free to pass that along. Obviously, reach out to us if there's any other information you're wanting on heat stress monitoring or specific to LSI heat stress monitoring equipment. Thank you to Stephanie. Thank you to Aaron and Sensodyne for co-hosting with us. Anything else that you want to? You want to add?
Aaron and I will field those questions. Any questions we didn't address online, we'll field them.
Yeah, absolutely. Okay. Well, thank you all so much and have a great day.
Yes, thank you.
Thank you, guys.